Okay, Michael, we're going to bring you up on stage.
So I'm going to change it up a little bit from what we've generally been focusing on for a lot of this conference. A lot of our talks have been a response to the immediate flooding that's happened. But kind of along a similar vein of what Jim was talking about is when we're thinking about the future system that we need to have to respond to threats like climate change, we need to do some advanced planning. So I'm going to be talking about how we can reimagine our river systems and our flood systems for greater flood resilience, but also ecological and water supply resilience. How can we use rivers, which are great at conveying water, to also recharge? It's not really an original thought, but reconnecting floodplains has great capacity to increase naturally occurring recharge. Before I get too far, I should acknowledge the team that's worked on this. So we're led by Jenny Marr in the FloodMar program and Lori Clemuro-Chu in the Central Valley Flood Protection Plan. Both these groups have similar objectives, and it was a great study to align both of the kind of areas of objectives of the conservation strategy and FloodMar objectives, and then bringing in that component of also thinking about how we can combine those and think about flood risk reduction. For the consultant team, I work for CBEC Eco Engineering, and we also have Deborah Bishop here with Jacobs, who has been working on this project throughout, and Andrew's here with Larry Walker, and he's been working on some of the more recent efforts. So we've had a lot of people talk about the response to flooding. Director Namath talked about how Gavin Newsom told her, we need to make sure that we are capturing some of this flood water, right? We had a lot of water going through the system. We had just come out of a long drought, and all of a sudden we're in flood. And this is because we've designed our flood system to very quickly convey the water out through narrow channels out to the ocean, right? We have created a system that doesn't really serve the need that we have. And when we're kind of thinking about long-term, what kind of system do we need for a resilient future when we're having to deal with the impacts of climate change, when the floods are going to get much larger coming out of the Sierra Nevada, that can have flood capacity for these flows, but also have the benefit of recharging on floodplains, providing ecosystem services in different areas. And as we got further along into the year, we saw a lot of the immediate responses, a lot of the great work people in this group have done to capture immediate water, incredibly necessary. And we're starting to see the next steps of what can we do to prepare our system for the next set of floods. There was a Newsom bill to fast track work on the Pajaro levee. And one of the challenges there is that requires thinking ahead. They've been trying to repair the levee in Pajaro since the 1950s, right? So how can we think about in the next 10 years as we're trying to work on this infrastructure, not just designing another flood system with taller levees, but how do we build these resilient features like floodplains that activate and provide ecosystem services into our flood infrastructure? So the way we've kind of conceptualized this is a series of tools that have been compiling a lot of research that's happened over the last decade. The Department of Water Resources, CVFPP, Conservation Strategy, had the original idea of this FIP analysis, floodplain inundation potential. And that's a really simple idea of that we have these really robust hydraulic models that for a particular flow in the river, we know more or less how fast that water is moving, how high it is, and where that water is. And we can use those models to project outwards and say, if we set back a levee in a location or we reconnected a floodplain, where would we be able to inundate areas? Where is there additional capacity to give the rivers a little bit more room? And a lot of the work we've been doing lately builds on these original FIP concepts into this EcoFIP, ecological floodplain inundation potential. And we're kind of we're not solving a fundamental problem, but we're working on trying to take into account different components of the system. We're bringing in the hydrology, so thinking about over a 100-year period, what kind of flow regime do we get, and what are the products of that, and apply it to a real landscape that we're working with. So combining the physical elements of the system, the landscape, with the incoming hydrology. And that's incredibly important as we're thinking about different management strategies for the system, future climate scenarios, to be able to think about what happens when we reoperate our reservoirs. How does that affect in-stream processes? So EcoFIP, the intention is to compile all these processes, and we want to have different lenses to look at the system. Not just when does water inundate, but what does that do for salmonid rearing quality, for shorebirds, for recharge on floodplains. So we're adding multiple lenses to look at the river system. And the way we approach it, and I'm not going to go very far into the tool, I've done a LunchMar talk on some of that. I want to focus on some of the active work we're doing right now, as opposed to that. But we start at the really large system scale, right? Starting at the kind of watershed or reach level to think of where can we physically inundate floodplains? Where is it possible using hydraulic models? And a lot of what we're doing is we're translating available hydraulic models that engineers and hydrologists work with and making them more accessible to where is the river connected? Where is it not? Where are there opportunities? The next step in our analysis is bringing time into the equation. What happens if we run 100 years of hydrology through the system or an alternative management scenario? What kind of benefits do we get? And we think of things in terms of acre days of inundated habitat, or acre days of suitable rearing habitat, or acre feet of recharge in a given year from floodplain activation, or potential floodplain activation if we were to reconnect an area of floodplain. And then the third concept is everyone wants to get to the implementation phase, which is really important, but when we're thinking about river systems, it's really hard to get enough money, enough partnerships to set back a levee. It's incredibly expensive. So these are big projects that take robust planning and partnerships over decades to make sure we have the investment needed in our infrastructure so that it is useful and resilient in the future. So we have worked on four, separate but related pilot studies. The first is on the Upper San Joaquin River, where a lot of these kind of original graphics came from and where we've talked about most. Since a couple of years ago when we started this process, we've expanded to the Pajaro Valley. We're now working on the Cosumnes River and also on the San Joaquin Regional Flood Management Plan area. So extending our work on the San Joaquin from Bryant Dam all the way down to the Merced River, including the flood bypasses. And I'm just going to give kind of brief overview of some of the work we've done in each of these pilot studies, but there's no way I can show all of the work or all of the details, but please come up to me and talk about them if you want to hear more. So on the San Joaquin study, a lot of our first work was those first two phases of EcoFIP that I was showing. The identification of opportunities, evaluation of what those physical opportunities were, and then prioritization of those concepts. Where should we actually develop concepts? And then our team looked at those priority locations and we came up with, how would we restore these areas? How would we reconnect these gravel pits to provide a flood attenuation benefit or a recharge benefit during times of high flows? How could we set back a levee? And then the benefit quantification piece of, if you set back a levee, activate an area of floodplain, what would that achieve? How does that change floodplain inundation, habitat, and recharge? Another piece we built into this is a way to estimate costs. So how much dirt are we moving around to make those physical modifications to the landscapes? And these are a lot of tools to kind of rapidly think through concepts, visualize them, and then quantify the benefits. It's not an engineering level design, right? It's not going to 65% design, but it's a quick way to get a lot of people in the room to look at a concept you have an idea. Let's look at what it might do. Let's look at what it might cost. And where we are going now is we have kind of honed in on an area of river that's really degraded. There's a bunch of old relic gravel pits where they've taken gravel out of the river, and now the river is kind of flowing through these different gravel pits that are too deep for rearing salmonids. And then there's also some opportunities to reconnect some areas for potential recharge. If you're interested in learning more about this work, DWR has created a story map where we have a lot more detail on some of these studies. And then Kevin mentioned the fine scale AEM that they're doing on the San Joaquin too. And this is going to be really important. The picture there is not the fine scale AEM. I'm sorry, we have the old picture. It just came out. It's going to be way cooler and way more 3D and higher resolution. But we're going to be able to answer really important questions of, how much recharge do we think we're going to be able to get in these large gravel pits if we reconnect the floodplains? Where does the water go? What's the distribution of coarse materials that we could potentially use for restoration? Those are the kinds of questions we're trying to answer with these new data sets. And we're basically looking at a 5-mile reach of river, coming up with a rehabilitation plan for the floodplains and the in-stream processes to kind of bring back a functioning river system in this area. Going downstream, not in order of chronology, we haven't really started that much of this work yet. We're doing some of the initial modeling where we've taken DWR's CBFED modeling, which includes the system-wide flood modeling. And we're now going to be looking at the rest of the San Joaquin River and the flood bypasses going all the way down to the Merced River. So we're going to be doing the similar eco-FIP analysis, looking at where there's opportunities, where we could do flood attenuation basins, where we could do levee setbacks, modeling some different concepts. Some of the really interesting things we can look at in these kind of systems are what happens if more water goes into the east side bypass or the old, the San Joaquin? How does that affect habitat over a 100-mile stretch of river? How does that affect habitat in a potential restoration concept? There's a lot of possibilities in these areas that I think several people have mentioned previously where, we're pulling water off the flood system at times, but there's lots of ways that can be done. It can be a levee setback. It can be a disconnected area that we use gravity to move water off of the flood system for transient storage. So we're starting to explore some more of those opportunities in this area. And then Pajaro is a really interesting case study that we've done recently. I mentioned Pajaro earlier with that newspaper article, and there actually is money now for them to rebuild their flood system. They're looking to add 100-year flood protection to an area that currently has 8-year flood protection. It's a Corps and DWR funded effort. And what we came in with is, they're building higher levees, but also setting some of the levees back. What is the potential with that space within the setbacks? What could we do to make that not just a flood project, but to increase the ecological function of the area, to provide steelhead for the threatened Central Coast steelhead rearing habitat? And what can that do to balance the water budget in Pajaro, where they usually run a deficit? And some of what we did was kind of the broad scale analysis of potential opportunities, which included areas outside of the currently planned flood project. And then for each of the areas where the Corps is planning on setting back levees or building new levees, we looked at potential concepts. What would happen if we implemented a side channel? And it was really interesting to find that the Corps was really receptive to these concepts, because to build new levees, to improve the flood infrastructure, they need material. So we were able to show some concepts where they source material from the floodplain, which is needed to increase floodplain activation and recharge, and use that to construct the new levees. And that could give them a big cost saving as they start to implement this project. So they've started on the first reach of this project. Now they're going to be continuing on to several of the other reaches. And we're hoping to continue to engage with them in this planning level work to think about designs that improve flood capacity, but also increase recharge in this area, further set back the levees, and then even looking at, what is possible downstream of where they're currently planning to do a project. There's a lot of issues. There's seawater intrusion. There's the groundwater out of balance. Another thing we've kind of looked at is conceptual designs for all of the project reaches, going outside of the flood project and seeing what is the total potential. Is there a significant recharge possible on the floodplain that would help offset the imbalance that currently exists? How is that balance going to change in a future climate? And what we see is there are significant opportunities here, and we're going to kind of help refine, this analysis and the work as we get to kind of a more realistic design phase. The other really important part of this work is the Jacobs team created a hydrologic model and applied that same decision scaling process that Jim was talking about recently, where we don't look at kind of a large general circulation model, but rather we think about, if the temperature gets a degree hotter, what are the physical implications of that? How does that change the flood risk? But also, how does that change the floodplain inundation? So we're actually modeling those 30 simulations that were mentioned of different combinations of increased temperature, reduced precipitation, increased precipitation, then running them through EcoFIP to look at how that would affect floodplain inundation. And I don't have time to go through the 50 slide decks of different outputs of the climate modeling results. But the key takeaway we found is, it's not a snowmelt dominated system. So you do see an increase in flood risk, which is really important to share. So that was a really significant outcome of this work. But also that the concepts we were looking at, the levee setback and floodplain rehabilitation concepts, in almost all cases where we would have reduced precipitation and less floodplain inundation, we could offset that amount of reduction in floodplain inundation by our conceptual designs where we've recontoured the floodplain. So we actually have adaptive capacity through these levee setback concepts to build resilience in the flood system. And I think that's a really important story to tell going forward. And then just a snapshot of where we're going next is we are working on the Cosumnes River study. We were just getting into the fun part of that, where we are getting through the EcoFIP analysis. There we've updated a DWR model that was created in response to the flooding. So we've taken that hydraulic model and we're developing a hydrologic model. We're going to do the climate change analysis again. We're going to integrate those results into EcoFIP, look at floodplain opportunities, develop conceptual designs. Then we're actually going to see, how do those conceptual designs reduce flood risk? We're going to bring them back into the hydraulic model to look at how do we lower water surface elevations by levee setbacks or other conceptual designs. And then the final piece of that we're adding on, is we're always trying to kind of add on to these studies, is groundwater recharge. The Larry Walker and Associates team with Andrew is going to be taking the results of our work where we estimate kind of recharge flux into the surface and say, we'll hopefully refine those estimates, but also say, where does that water go? And, over what time scale? Does it go back to the river? Does it go to the aquifer? And how does that happen for existing conditions and the conceptual designs that we've developed? And that's just an example of some of the initial modeling we're doing. So I guess to close, through all of these different pilot studies, we're always trying to add new pieces. How do we look at flood risks? How do we add additional lenses to look at things like shorebirds, to look at not only levee setbacks, but things like transient storage and more of the flow-through basin concept? How do we incorporate the new geophysical data, the AEM data, to better inform where we do projects and our estimates of recharge? And then a big piece of this work is visualization and being able to share all of the work with the people that want to see this work. So we're trying to make the results of this very accessible by sharing it on the story maps, and hopefully a lot of the data will be available as well. But in the end, success is definitely going to be measured by implementation. And we recognize that's not just one group that's needed to do that. That requires the whole community and probably people beyond who's in this room. So we really look forward to working on these pilot studies, but also progressing them to the next level. What does it take to get these to projects in the ground that really give us the flood resilience that we need in the future? Thank you.